And our sum and difference identities can also appear in proofs. So again, this question says prove, this is example 3. And on the right-hand side, I have sine of x. So there's nothing you can change. Well, you could change it to 1 over cosecant, but usually, as we've seen, one of our strategies is change things to sine and cos and write things as a single fraction. So if you have sine of x, it would seem to complicate it a little bit more to change it to 1 over cosecant x. So I would leave the right-hand side as sine of x. And then when I look at the left-hand side, I've got sine again. So there's nothing I would change that to. I could change it to 1 over cosecant, but again, I don't think that would help me. So the only thing I have here is I've got two things subtracted inside the sine function. So if I think of this as alpha and this as beta, I could write it as the right-hand side of one of our sum and difference identities. Now temporarily, this is going to seem like we're complicating things more than we're simplifying them, because we have one thing written here, and if I'm going to use the formula to expand this, I'm going to write four things. I'm going to have sine alpha cos beta minus cos alpha sine beta. So I'm using the formula and I'm substituting in the values that I have where the alpha and beta are in the formula. So once you've done that step, because that's basically the only thing we could do to start, is there anything we can do next? What's the value of sine of pi? Close. And what's the value of cos of pi? Negative 1. Yes?
Could you also use sine
Sine minus sine here?
Yeah.
No, because the only formula for sine alpha minus beta is sine alpha cos beta minus cos alpha sine beta. So if we have two things subtracted inside of sine, this is the only formula that there is. What's 0 times cos? 0. Negative 1 will be plus. Hey, we're done. So a couple of proof questions.